In the last clip, we saw that the two factors most responsible for the favorableness of redox reactions are the electronegativity of the atoms involved and the positive character. Electronegative atoms want to get reduced. Atoms that have a lot of positive character want to get reduced. I should give you the caveat that as you'll learn, for those of you who go on to Chem 2080, that these effects can be broken at high temperature. As you'll learn in Chem 2080, it is possible that at high temperature, the electronegative atom, instead of getting reduced, will get oxidized. We don't have to go into that. The only thing that we really need to know about temperature for Chem 2070 is, and this is true, temperature is all reactions go faster. This is actually, it will turn out not a comment on favorability, but just speed of a reaction. All reactions go faster at high temperature. If you want to get the dirt on your hand to react with a soap, you should use hot water because that reaction will go faster. Okay, so where are we going to use this? We will use this in understanding the metal activity series. And not in the first part. In the first part, we'll just look at what we know about electronegativity. And the question is, here's the periodic table. Here's the periodic table. And we're going to look at the reaction metal plus H2O or HCl or an acid. And the question is, does the reaction that the metal gets oxidized and the hydrogen gets reduced, is this reaction is favorable? And put in chat, this reaction will be favorable for metals that are electronegative or metals that are electropositive. Put it in chat. This reaction will be favorable for metals that are, put in chat, electropositive. Therefore, hydrogen is going to be the more electronegative atom. It will be the atom that wants to get reduced. And the region of the periodic table where the metal atoms are more electronegative than hydrogen is what I call group D. So here's group D. And we're just going to look at the most common metals. These are taken from your periodic table: copper, silver, platinum, gold, and mercury. And these metals are all more electronegative than hydrogen, and therefore this reaction does not occur. That's group D. The next question is, what if we used a more active form of hydrogen? Let's look at a metal that does not react with water. This reaction does not occur. So regular water doesn't have what it takes, but an acid, remember that acids have greater plus character than the hydrogen. They're more likely to occur. This reaction does occur. So you need an acid to get the hydrogen reduced. And they will be the metal atoms closest to the group D. They will be located on this side and on this side. So this is group C. They can't react with water, but they can react with acids. And common metals that are in that group C, are cobalt, nickel, tin, and lead. And the feature is that if you count, and we're not going to count along the diagonal, these elements are 3 or 4 steps away from gold. Let's look at cobalt. Cobalt is 1 step to nickel, 2 steps to copper, 3 steps to silver, 4 steps to gold. So it's 4 steps away from gold, and it belongs to group C. And there's one exception to that. Zinc is not a group C element. Zinc actually can react in water. So we will skip B for a second and move all the way to A, group A. And group A are going to be the metals that are the most reactive. So here's the A group. The metal reacts with cold water. Remember, do reactions occur faster at low temperature or high temperature? And the answer is they react faster at high temperature. So if the reaction goes at cold temperature, it's an easier reaction to go. And put in chat, if the metal gets oxidized with cold water, will the metal get oxidized with acid? So if the first reaction happens with water, the hydrogen and water, will the reaction occur in acid? And the answer is yes, because in acid the hydrogen is more positive than in water. So if the reaction already occurs with the hydrogen and water, it will occur in acid, and that's group A. And group A are the most electropositive metals. They are remember that columns 1 and 2 are in the main group series. So we're looking at distance from fluorine. And the alkali metals are all very far from fluorine. And among the alkaline earths, the 3 alkaline earths that are farthest from fluorine are calcium, strontium, and barium. And it's very often that the heavy alkaline earths react the same way. So I call them the 3 amigos. It is the group A consists of the alkali metals and the 3 amigo alkaline earths. And finally, what is group B? Group B is going to be the metals that do not react in cold water. So that reaction does not occur, metal oxidized and H2 reduced. But you can speed up the reaction by putting it in hot water or steam. And under these conditions, the reaction does occur. And the group B are all the remaining common metal atoms. I show them here. Magnesium, titanium, chromium, manganese, iron. There's zinc, the exception, and aluminum. And I've chosen these metals because these are the metals that are listed inside your textbook. That is the metal. This is the metal activity series. And it's actually a series that practicing chemists know because water is super important and you'd like to know which metals react with water. Okay, so there's one other series that's in your textbook about redox. It's a very simple one. It's the halogen activity series, and it comes straight from the rule that we know. Fluorine is the most easily reduced. Iodine is the least easy to reduce. And with the understanding of the metal activity series and the halogen activity series, we can just directly solve the following questions. Which of these reactions are favorable? And favorable's exact definition means it goes more than 50% to completion. So the first one is HCl plus gold going to an oxidized metal plus a reduced hydrogen. And the question is, which group does gold belong to? And gold belongs to group, put it in chat, A, B, C, or D. It belongs to group D. And therefore, this reaction does not occur. Group D do not react with acids. We can try the same problem now. HCl, the second problem, plus cobalt. Does this reaction occur? Cobalt Cl2 plus H2. And again, the key question is, where is cobalt in the series? And cobalt belongs to group, put it in chat if you remember, Cobalt belongs to group C. And group C means they will react with acid but not water. So yes, the reaction does occur. Third problem. NaF plus Cl2 going to NaCl plus F2. Let's do some oxidation states. The F is -1 here, 0 here. The Cl is 0 here. All elements, pure elements, are 0 to -1. The F is getting oxidized, but fluorine is the more electronegative atom. This reaction does not occur. And then we'll do the last problem. Zinc plus very hot water, which is steam. And the question is, does zinc get oxidized to zinc O plus H2? And again, the question is, which group does zinc belong to? And remember, zinc is the exception. It is in group B. And elements in group B do react in steam, hot water, and so the reaction does occur.